So this video is a quick walkthrough on how to calculate the length of a common rafter. We're going to go through calculating the line length, which will take you from tip to edge of building, and we're going to calculate the overhang based on the given projection. So we have some givens on the sheet here. The span of the building, which would be outside wall to outside wall, in this case is 4,000 millimeters. And we have a roof slope of 412. Projection will be 600 millimeters, and I've got a couple different measurements here or a couple different examples here for a ridge stock and rough fascia, which will come into play after all the math is finished. So we'll start with some triangle math. Okay, the three triangles. So we have the slope ratio, which is a 412 pitch, meaning for every 12 on the horizontal, we go 4 on the rise. And remember, that's a ratio, so these aren't any units. They can be any units, it's just a ratio, 12-4 pitch. Okay, we have another triangle based on the run of the building. So the run will be half the span. In this case, the span's 4,000, so the run is 2,000. So what I've done is made a triangle here, put the run at 2,000 on the bottom, and we're going to be calculating the line length of the rafter, which would be the hypotenuse of this triangle. And we have a third triangle indicating the overhang of the common rafter, and we are given a projection of 600 on the sheet, so we're going to draw the triangle in the same way and indicate that we have on the horizontal 600 millimeters. And again, we're going to be figuring out the hypotenuse of this triangle as well. So lots of triangles, and the suggestion in this walkthrough is to use Pythagoras to determine the hypotenuse of the slope ratio triangle. Because you already have two dimensions of this triangle, we can easily determine the third using Pythagoras, which is based on the right angle triangle principle. So what I've done here is indicated this: the rise, or 4, will be A, the run, or 12, will be B, and we'll just punch that into our Pythagorean theorem. And I've gone through the math here for you, determined that these two squared equals 160, but we need to take the square root of this to get C. And when all that is said and done, I got 12.649. Again, this is not in any units. This is a part of the ratio. Now we're going to use this triangle with all the three given sides to determine the hypotenuse of the other two triangles. Okay, so here's the little triangle that we have with all three sides. It's almost like a key to the rest of the problem. And we're going to proportion that off against our larger triangle to determine the line length of the rafter. So here we have our 2,000 millimeters, which is the run, and we're trying to figure out the hypotenuse. So this is just a ratio and proportioning, and it can be written as a fraction, which I find to be easier to remember. In this case, we're trying to solve for x, so I put the x on top, and I put the 2,000 on the bottom, and we're going to have to proportion that off with the sides of the triangle that match. So I've got the hypotenuse of this triangle on top over here, and I've got the horizontal dimension on the bottom here. And once we have that, we can cross multiply these two, and then divide by what's left on the bottom, and we can solve for x. We get 2108 millimeters. Now this was a fraction. I rounded down. When we're dealing with decimal places of millimeters, the measurement is so small we can easily round that down and drop it, which is not always the case if you're dealing with inches or feet. You just have to think about the size of the dimension you're working in. So we do that exact same process for the overhang here. Again, I've written it exactly the same, except for in this case, we've got 600 millimeters for our projection, and we're going to try to figure out our overhang on the slope. So same thing, draw it exact same way, cross multiply, divide by 12, we get x as 632. Okay, and those are basically our answers, and that'll determine our rafter length. And here I've drawn out the rafter length for you, indicating, so if you're laying this out on your 2x stock or whatever it might be, your first working point, you measure down your line length of the common rafter, give yourself that line. At the plumb line, these are all the same plumb line determined by the framing square, 412 framing square. And we're also, from this working point, we're going to measure 632 over and give ourselves another plumb line. Once we've done that, we can determine where our bird's mouth needs to be to sit on the wall of the building. The only real rule here is that you should leave at least 2/3 of this distance, this total distance of plumb line. You should leave that much on the rafter stock. You don't want to cut out half of that distance. So 2/3 is your general rule of thumb there. And we have two adjustments. I'll just scroll down here. So at the ridge, we're going to subtract half the thickness of the ridge stock perpendicular to the plumb line. In this case being 19 millimeters, since we had 2x stock as our ridge. So I'm indicating that here, not easy to see, but from our original plumb line at the working point, we are going to come back perpendicular from the plumb line, not to be confused with coming down the slope. That would be wrong. It would give you a different dimension. So perpendicular from the plumb line, come back 19 millimeters, and you give yourself a new plumb line. And that'll be your cut line. And we do the same at the bottom. At the tail, subtract 1 full thickness of the rough fascia. In this case, it is a full 2x dimension, which is 38 millimeters. So it's an identical process to the top, except for we are subtracting the full thickness of the fascia perpendicular from the plumb line, drawing ourselves a new plumb line indicated with the dashed lines. And now we can cut our rafter, and that should fit nicely. And one last tip for you: if you're given a problem and it's in imperial or standard measurement, you're given something in feet and inches and fractions, before you get into any of the triangle math, my suggestion is for you to convert everything into the same unit. So if you're in feet and inches, put everything over into inches or feet, and decimals. Take the fractions out, so it's something that you can punch into your calculator. And then when you get to the very end of the problem, you convert it back to feet, inches, and fractions of an inch. So it can feel like a longer process, but you want to do that all right now before you actually get into the triangle math if you're dealing with imperial or standard.